So when we left off on Friday, we were discussing the public trust doctrine, and we were trying to figure out where this came from. I know you all were focused on this over the weekend, madly doing research, trying to figure out the heart of the law. What kind of law gave birth to the public trust doctrine? So we talked about different possible kinds of law last time. We talked about the Constitution, right? So the supreme law of the land. We talked about judge-made law, common law. We talked about statutory law. We talked about administrative law, those being the major kinds of law. So what kind of law is the public trust doctrine? Yeah.
So it's per state,
Mm-hmm.
and they came into the union on equal footing, and so I thought it was that they had brought their inherent sovereign power, public trust responsibility came in when they came in part of the union. So it actually is like an inherent power and doesn't technically come from one of the major sources.
So is that like, it's not, is it written down anywhere?
No.
In some places it is, right?
They have
Hawaii,
some
they
state constitution.
Yeah, Hawaii, they put it in their state constitution. A couple of other states have it written there. Generally, though, it's not, right? So generally, it's not in the Constitution. States can pass laws to like execute it, so you can get some statutory expressions of it. But then, if it's not constitutional because it's not written down, which is generally where you find a lot of those kind of sovereign powers, police powers. What are other police powers that are like this? Are there other police powers that are like this?
That aren't in the Constitution. I mean, I can think of police powers. I'm just trying to. They're all constitutionally.
Do states have to use their police powers? Is there like a positive requirement on police powers?
Well, they can't neglect their duty to protect the citizens. So
So do you have a cause of action against the state if the state's not like doing zoning or something? Or
if they're not doing zoning.
zoning being a major police power, right? I mean, Houston's chosen not to. If you've been to Houston, it's a mess. But
Well, no, that's not a cause of action. There'd be a cause of action if they stopped protecting the general welfare of the people, their citizens.
is there? I don't know that we've. I can't point to a lawsuit where we've seen that.
So
There might be. Maybe I'm just not aware of it.
I guess that's more when one state is harming another state's citizens. I was thinking.
Definitely that. Yeah, you were right to protect your citizens from another state.
Right, and then the case you read about the fact that like a riverbed
Mm-hmm.
you read about that is held, that was something separate. They have to hold on to that because if they don't, they're not protecting the best interests of the public, and that's an inherent sovereign.
But that's part of the public trust.
Right.
Yeah,
So I'm trying to think of other powers.
that are like that.
Yeah, and I can't think of that.
I mean, there's definitely other powers where the state has powers because of its role as a sovereign entity. It's not clear that we have other powers like this where the state has responsibilities that it can't waive, right? Okay. Other thoughts on where this might come from? Could it be common law? Judges say it exists, therefore it exists. What are some characteristics of common law?
It became common law in the Illinois case.
Okay.
Before that, it wasn't. I mean, the way it turned into common law was through the Illinois case and the cases after that followed after that.
So what are characteristics of common law? How do we know something's common law?
It's established by it's case to case.
Okay. So if you have judges who are making common law around negligence, right? Negligence is a common law cause of action. It's kind of a traditional thing. Where do we look to now to see what the elements of negligence are?
A case.
Not
Well,
cases.
Second restatement.
Second restatement, which is only if it's been
But you get
adopted.
that from a case, right? They cited it in a case.
Well, it comes from a case, but once it's adopted, almost every state has adopted one of the restatements of torts. And once the
Right, okay.
legislature's adopted it, it doesn't matter what the state's courts were doing before, right?
Yeah.
they've replaced the common law with statutory law. And there's certainly still common law out there, but that's one of the characteristics of common law is that the legislature can always step in and change what that common law says and actually change how it works, right? But if you go back to the very first case you mentioned, Illinois Central, if it's common law, then the court should have deferred to the legislature by changing when the legislature changed the common law. And in that case, what they did was strike down what the legislature did. So can it really be common law? If it's not able to be changed by the state doesn't have the power to get rid of the public trust doctrine? So who gets to say what the public trust doctrine protects, what the public trust doctrine means? After Mono Lake, could the California legislature come in and change the public trust doctrine? You think so?
Apparently
They
not.
could add, I don't know if they could take away.
Yeah, maybe it only goes one way. Maybe it's a ratchet. You can protect more.
Yeah, I don't know what, yeah, once it's set, I don't know how you would take it away at this point.
If only the court can do it. Yeah. Okay. Other thoughts? So there's not an answer to this question. This is something that's very troubling definitely for scholars who look at this. And it's also troubling for people who just think about, like, what does the public trust doctrine mean? Judges are kind of scared by it because they don't have any guidance. It's up to them. And no one's going to come and fix their mistakes because the way we've set it up, the legislature can't override the public trust doctrine. So something to think about as you think about this doctrine, but undeniably it produces good conservation outcomes, right? We have better, more protected environment because of the public trust doctrine. But kind of foundationally, it's not clear where it comes from, what the limits are to what can be addressed with the public trust doctrine. So really an interesting area of law really still being developed, and one of these areas where the kind of academic foundation of the doctrine matters a whole lot, because that determines exactly how much power this doctrine is going to have over the state. All right, some other developments. It's very local, the way it's developed across the state. As you said, it goes state by state. So Pennsylvania still has these are just some examples. Pennsylvania has a very traditional public trust doctrine. Florida has included views and shorelines in their public trust doctrine. A very big focus on shorelines, public access to shorelines, protection of shore ecosystems. Michigan brings in the Great Lakes in a big way. It protects those a lot more than you might otherwise expect. Clarity of the lakes, ecological health of the lakes. But also reads in a reasonableness requirement that we don't have in a lot of states. And then Hawaii, it's constitutional, recognizing the value of the Constitution in Hawaii. New Jersey is really focused on shoreline access. Same with Oregon and Washington. It's all about getting people into these places. So the way it plays out is it really varies quite a bit across the country. And certainly if you're practicing in another state, you need to know what this background principle looks like in that jurisdiction. So generally, most places, it does apply to inland waterways. Big questions about which ones it applies to, what is actually navigable, what's not navigable. We talked about in Colorado, there's one river. In Kansas, there's 3 rivers. In California, virtually every river is navigable. A lot of times it's used for public access. California does this, Montana, and then a lot of the coastal states do that. Colorado doesn't do this for public access. So most of the rivers in Colorado are technically closed to public access. You can be charged with trespass if you float down a river that goes over somebody else's property. Water rights, it's all over the place. Some places they bring it in. California brings it in for water quality. No other states look at water quality. Most states are just looking at water quantity. So no traction on non-water-based protections yet. There's been some efforts to push a public trust in air, which we saw back in those the Institutes of Justinian, right, the ancient Roman law. So you can look at something like climate change or air pollution as a public trust issue. Hasn't really gotten legs yet, but potential. And then little application to the federal government. So feds can be subject to it under state law, which we see sometimes in California, but generally there's not a federal public trust doctrine that protects federal lands anywhere. All right, any last questions on public trust doctrine? Yeah.
So I just want to be clear, the second bullet point is saying that the public trust doctrine is only applicable to issues of water?
For this one? Yeah, generally it's just been seen for water. There's some effort right now, there's a case going looking at climate change. what's the name of that case? Something about children and the future, and it's very cute and touchy-feely. And that action was just allowed to proceed. I think it got through a motion to dismiss or through a motion for summary judgment. So it looks like it's headed towards trial. So there may be progress in that area in the near future, but nothing quite yet. All right, other questions? If you're into stream access, fishing, floating, any of those things, public trust dovetails really nicely with that. At some point, there's going to be a cookies and conversation where I'm going to talk about that, but we're not there yet. So, yeah, cookies and conversation. These are the things we're supposed to be doing at the law school. We do occasionally where a professor talks about their research with students or about something they're interested in with students, and there's cookies and conversation.
This year.
Hmm?
I don't think we've had many of them this year.
We have not. We had a bunch. We had a couple last year,
Yeah,
but it's
we
just
had
been.
a few last year, I feel like.
Yeah, so at some point, but it's also professors, I'll see those first semester as the academic dean, and so I think she's figuring all of that out still. But I think it will happen soon. All right, so toxics and uncertainty. Before we get into RCRA and CERCLA, we're just going to talk a little bit kind of high level about toxics and uncertainty. First, toxics seem to be one of these things that people really get freaked out about. People definitely spend a lot of time worrying about toxics, about pesticides on their food, about toxics they're breathing in, toxics they're getting on them at work. And if we go way back to the very beginning of the semester, we talked about themes and the way people perceive risks. This is one of those things, right? Like this is an unknown cancer, something that everybody worries about. And so if there's some chemical that you could get exposed to now, maybe not even know it, and then in 30 years it's going to give you cancer, like that's a terrifying thing, right? So people do spend a lot of time worrying about this. But if we look at causes of death, it's not super high on the list. So this is for number of American deaths on average annually, and then days of life lost, meaning how old were the people who died on average. How that computes out to tell you on average how many days of life do you lose based on this particular activity. So it's a little weird because if you don't die in a car wreck, you're not losing those days of life. But if you're an average American, you're losing 182 days of your life to car wrecks. Make sense? People okay? No? Yes? Kind of? It's a way of calculating it out, right? And saying if we have, you look at all the people who die in car wrecks, you look at how many more years they would have lived if they had not died in that car wreck, and then you divide that number of additional days that they would have lived by the total population of the United States. So you can tell not just are people dying, but are people dying younger or older than they otherwise are. So it plays out in homicide, where you only have only 26,000 people dying of homicide every year, versus you've got, let's see, air pollution, 55,000 people dying of air pollution every year, but homicide is costing people more days. Anybody have any idea why that would be?
Younger on the impact.
Yeah, exactly. Who gets killed in homicides?
Yes.
It's like 17, 18 to 30-year-old males generally, right? So a lot of those people dying, even though it's a much smaller number, air people is generally killing older people, just killing them a little bit earlier than they would otherwise die. These people are getting killed when they have a lot of years left. But if we're looking at kind of the hazardous waste side of this, hazardous waste kills about 1,000 people every year. So it's 4 times as risky as flying, but way less risky than house fires, way less risky than air pollution, which we live with all the time here, way less risky than driving. Pesticides, 16,000 people per year. Still way better than air pollution, way better than vehicles, way better than driving deaths. Smoking, like if you smoke, it's hard to complain about the rest of the stuff when you're already looking at 2,000 days of life. And this is only for smokers, it isn't computed across everybody, but just looking at smokers, how much more damage you're getting there. So it's definitely a big thing, certainly something people worry about. But maybe it gets a little bit more attention than it actually merits based on the number of people that it's impacting every year. And sure, it's different than driving. We choose to drive. You don't choose to be exposed to hazardous chemicals. But all the same, the actual risk isn't quite as high as we tend to think. I don't know if you can see this towards the back, but this is a table ranking 11 top environmental risks. This is the public ranking, and then this is the EPA's list of concerns. EPA's list isn't ranked at all. Public goes from highest to lowest. The highest risk, the highest thing that the public's worried about is hazardous waste sites, which doesn't even show up for the EPA. It's generally a small group of people who get exposed to any given waste site, so it's just not something they worry about. But the public has these visions, right, of a glowing pit someplace that's mutating them and killing their children. And that comes out of things like Love Canal, which we're going to watch a little video about today, which is this horrifying thing. You think everything's great, then all of a sudden you've got rashes and extra chromosomes, and it's like a problem, right? It's unexpected. But a lot of these things that show up that the public's worried about, we don't get nearly the level of worry from the EPA, from the people who actually study these kinds of problems. Last one on this, actual causes of death in the US, tobacco, about 400,000, alcohol consumption, about 100,000, poor diet and physical inactivity, about 300,000 in 1990. Numbers are higher, but roughly the same kind of ratios, although alcohol is actually getting better in 2000, which is kind of remarkable. But if you go all the way down, toxic agents is at about 55,000, so well below microbial agents, alcohol consumption, poor diet, and tobacco. And so a lot of other things that are more, that kind of merit more concern than we tend to look at generally. All right, the premature death, if you just want to look at that, it's about 200,000 people dying earlier, generally about 10 years earlier than they would otherwise die due to toxics. So when we talk about toxics, we're talking about chemicals that have a serious risk of harm even in a very low concentration. For some of these things, there's no safe level at all. We don't necessarily know like what level of benzene we can get exposed to without increasing our cancer risk. It may be that any exposure increases cancer risk later on or increases other risks of illness. Examples, lead, asbestos, pesticides, benzene, gasoline, right, tons and tons of examples of toxics that we see every day in kind of normal life. And we see these things because they're valuable to us. We like these, they call them economic poisons because we use them. They are tremendously valuable. They make our lives easier. And yet at the same time, they present risks that we possibly can't avoid with uncertain risks. And that's a big part of this is this uncertainty. So there's 10 million different chemicals that are being manufactured right now in the United States. We're missing data on like 95% of those. For about 95%, we don't really know what their impacts would be on people. Maybe it's even higher. The vast, vast majority, we just don't really know what the risks are associated with that. That's kind of a scary thing. Research is really expensive to do on these. It also tends to be long-term. We don't know how these interact when you're exposed to multiple toxics at the same time, the way that all of us would be, right? So when you're testing this stuff, you take a mouse and you expose it to one toxic and you see what happens, and then you extrapolate from this mouse to people. And there's all kinds of problems in going from a mouse to people. There's also problems going from one kind of toxic exposure to all these different toxics that we look at. So a lot of risks associated with this, and that's the central question for toxics, is how we handle this uncertainty. And we'll talk about kind of two different kinds of uncertainty and generally the ways we handle those two different kinds. First, our overall regulatory structure. The Clean Air Act and the Clean Water Act, as you remember, have special requirements for what we do with toxics. So that addresses toxics that would be released to the air or to the water directly. RCRA, which we're going to cover today, and CERCLA, which will start today, also address toxics. RCRA looks at transport of toxics and disposal on land of those toxics, not in the air, not in the water, but the stuff that stays on land, either getting treated and then disposed of or recycled. RCRA is kind of a cradle-to-grave approach to toxics. From the time a toxic is created until you finish with it, we should know where it is at any given point, how much of it there is, and to the extent we know what the risks are associated with that. The stuff that is either escaped from RCRA or the stuff that existed before RCRA came into effect falls under CERCLA. That's our Superfund Act. And so that's how we clean up places that are already contaminated. It is under CERCLA. FIFRA is agricultural chemicals. The FDCA, Food and Drug Additives. OSHA deals with toxics in the workplace. And the Toxic Substances Control Act essentially addresses everything else, stuff that doesn't get caught up in any of these other acts. So a lot of industrial chemicals that people aren't necessarily supposed to be exposed to. So the things we're going to talk a little bit about today in this first part is who bears the risk associated with using these toxics, and then how we decide or how the government decides whether these toxics can be used. Right? Do we decide that it's okay for for industry to use this particular chemical or not. And so when we talk about who bears the risk, what we're talking about essentially is, do the companies have to bear the risk of showing that these chemicals are safe before they can be used to the public, or used in a way that might impact the public? Or does the public bear the risk, and the company is kind of the default position is to let these chemicals come onto the market or let these chemicals be used? So you can look at something like FIFRA, the Federal Insecticide, Fungicide, and Rodenticide Act. And before you're allowed to use a new insecticide, fungicide, rodenticide, or any of the new pesticides, there's a really long toxicology test you go through, see kind of what the residues might be left on food, what the impacts are going to be on people eating that food, what the impacts are going to be on the people applying that pesticide. That can take, on average, about $5 million, about 5 years to get those things through the test procedure. So it takes a long time to do that, right? It's expensive. The company then is bearing the risk here, because the company is the one that has to show that this is safe before it gets released onto the market. And the standard in the FIFRA case is no unreasonable impacts on the environment. And you can look that up in the book if you're interested in kind of seeing a little bit more about what that means. Food and Drug, Federal Food, Drug, and Cosmetics Act, same kind of thing. Big tests, and all this puts the onus on the manufacturer to show that their products are safe before those products enter the market. Okay, so that's one way of doing it. And that contrasts with the Toxic Substances Control Act, which before you start creating or start using this new chemical you've created, you go through a pre-manufacturer notification. You tell the EPA, hey, we've got this chemical that we want to start using. There's no testing required at all at that point. About 15% of the chemicals will have some kind of data on them presented to the EPA, but there's nothing that's required at this point. If they have data, they're supposed to submit it, but no required data. So then the EPA has, 60 days to tell the company if they want additional tests. So they can require additional tests if they don't have any info to assess toxicity, and the chemical may represent an unreasonable risk of injury to health or the environment. But they don't have any data on that 85% of the time. And so they're making a call as to whether there is an unreasonable risk of injury to health or the environment, or whether there may be that risk without really knowing anything about the chemical. So you can look at the structure of the chemical. Is it similar to something else that's already on the market? Is it a chemical analog that may have similar effects to something that's a known carcinogen or another known toxic? And so the EPA gets that 60-day period to make that call. They can ask them for data, or they generally don't. And if they don't, then if there's no block within 90 days, that chemical goes on the market. And that's it. So for those, the onus is on the EPA. The public is essentially bearing the risk of making mistakes. The public is bearing that risk of not knowing what these chemicals do. All right, to give you an idea, only 60 tests in the last 5 years, 85% of the PMN, the pre-manufacturer notification data, is deficient, and 67 on the chemical's health effects, and 67% are deficient on health or environmental effects. So most of these we don't really know anything about. Post-release, we may find out if there's a problem, but the vast majority are released and we just don't know, right? We don't really know what the long-term impacts of those are, which is fairly terrifying, I think. But that's the way we do it. And generally, these aren't chemicals the public's interacting with. These are industrial chemicals that show up in industrial processes. All right. So the first question was who bears the risk. This is the other question, which is how do we decide whether these chemicals can go on the market or not? So first, who has to demonstrate that they can or can't? Second, what are we actually demonstrating? Generally, the kinds of regulatory standards fall under 3 categories: health-based standards, feasibility-based standards, and risk-benefit, kind of a cost-benefit analysis. So health-based could be something like must prevent all significant risk, and the feasibility standards could require reduction to the level that's technologically or economically feasible. So what can we do based on what we know right now to make this as safe as possible? Or economically, how safe can we make this new chemical without making it so expensive that people can't use it? And if we look through our statutes, we see different ways of doing this. So if we look at the Federal Drug and Food, Drug, and Cosmetic Act, there we go. Look at the Delaney clauses. The Delaney clauses require Food, Drug, and Cosmetic Act. I always get that one wrong. Food, Drug, and Cosmetic Act, Delaney clauses ban any unsafe food, drug, or cosmetic additives. So we're looking at stuff that's added to the food and say that we can't add if it induces cancer risk in man or an animal. And the FDA tried to allow additives that had a very small risk of increasing cancer risk. 1 in 9 million they let through, and then 1 in 19 billion. And we've got a lot of people on the planet. We don't have 19 billion yet. So statistically, even if everybody on the planet got that additive, we wouldn't increase the cancer risk by even one person. But the court said, even in these cases, there's no de minimis exception. There's a health-based standard. The health-based standard said you cannot release a drug if it's unsafe, and unsafe means it induces cancer risk in man or animal. Women too, I assume. Mankind and animals, I should say. So the reason here is maybe that we don't see a lot of value in these additives. You know, it's a coloring agent or something for food. We were just not willing to take that risk if we're going to be eating this, and we don't see a whole lot of benefit to changing the color of food if there's a chance of creating cancer. Clean Air Act is similar, not looking at toxics, but looking broadly at the Clean Air Act when we decide which of the which pollutants we're going to regulate under the National Ambient Air Quality Standards. We're not allowed to look at cost when we're figuring out what we're going to regulate or determining the levels we're going to regulate it at. So all we're looking at is human health. Right? It's again a human health-based standard where that's really the focus, and nothing else matters too much. Other examples, OSHA says these chemicals have to be safe to the extent feasible. Feasible means economically and technologically feasible. So we protect these people who are working with these chemicals much less than we protect the public from additives, for example. Safe Drinking Water Act, we have a maximum contaminant level goal, which is purely health-based. How many of you get the little, I don't know if have we talked about this yet, whether you get info on what's in your drinking water? Okay. How many of you get a little handout with your drinking water or from your water company? How many of you are on electronic billing? Yeah, that's why you don't see it. Okay, so it's one of these things it's a statement that's in your bill that you never open because it just gets paid automatically. But if you went online and viewed your statements, one of those statements will have an insert in it every year that tells you how clean your water is. You can also look it up online and it'll tell you what's in your drinking water. So we have these, one of the things we'll tell you is what the maximum contaminant level goals are for your drinking water. Those numbers are purely health-based. If we are only considering health, how high would this standard be? How little, say, lead could be in your water, how little chromium, how little whatever could you have in your water? Those are often zero because the EPA just doesn't know enough to set it at a higher level. And so the assumption is you shouldn't have any of that bad stuff in your water. But that's not the binding standard. The binding standard is a maximum contaminant level, the MCL. And that's how much you're actually allowed to have in the water. And that's set as close to the maximum contaminant level goal as is feasible considering cost and technology, or was historically. But then in 1996, MCLs were adjusted to a cost-benefit ratio, meaning the new standard is to maximize health risk reduction benefits at a cost that is justified by those benefits. So initially it was a feasibility question, and then in post-1996 was shifted to a risk-benefit analysis. Does that make sense, everybody? You see the difference between these different approaches? Okay. All right. Other ones that use risk-benefit analysis, FIFRA and the Toxic Substances Control Act. In either case, the EPA can ban or restrict the chemical if there's a reasonable basis to conclude the chemical presents or will present an unreasonable risk of injury to the health or environment. And unreasonable is read by just everybody, the courts, the agencies, to require a risk-benefit, a cost-benefit analysis. All right, questions about those? One other approach that we see, the last one I'm going to mention, is the informational approach, the idea being that if we give people information about these things, then that lets the political process work, and people can respond to concerns about toxics because they'll know what toxics are in their community. And EPCRA is the big act that addresses this at the federal level, the Emergency Planning and Community Right to Know Act. There are a bunch of substances that the EPA has listed, and if you have over that threshold, over a threshold amount of that hazardous substance, then you have to complete a form and report to the EPA that you have that substance, and that will bring you into the toxic release inventory. And so you can look up on the toxic release inventory either the tox map from NIH or the scorecard, which the EPA puts out, and that will tell you what there is in your community, how many of these places have reportable levels of hazardous substances. So either you can go and protest them, or when the big earthquake comes, where not to go because there are toxics there that might be being spilled. Or when things are flooding, places to stay away from. It's both for the community, for like all of us to know, but then especially for the groups that do emergency planning, right? When Houston flooded, for example, there were a bunch of semis that had these chemicals that had to be kept dry, otherwise they'd blow up. And they weren't able to keep them dry because of the flooding, and they all blew up and had big fires there. But they knew those chemicals were there at least because they were within the toxic release inventory. So at least you knew it was coming, I guess. Go ahead and take a moment and look up on either one of these, your home area, and find a couple interesting chemical stockpiles. So you will sleep better tonight. Oh wait. Yeah, I take it down too fast.
Yeah.
I think it is scorecard.org. Yeah, that's good. Good news, the administration has not taken that data down yet. So. Which county?
Here.
Us?
Sacramento County.
Yeah.
Dirtiest worst 10% of all counties in the United States in terms of water releases and recognized developers of toxins.
Nice. Don't drink the water.
There's a development on 19th. It's by the dog park.
Where?
It's pretty close. It's by the city of Safeway over there, and it's called Brownstones. But it's actually a brownfield
Not just a clever name.
development site. So I'm just saying that.
Thoroughjet for sure.
I was like, why did they keep that name?
And I get why you want to do brownfield redevelopment, but it just rubs me wrong, especially in life.
They're gonna be expensive.
Love Canal.
Yeah, they're gonna be.
Just asking for trouble.
Is Aerojet the property going to Folsom on the right?
Which one?
Aerojet?
I have no idea.
Okay.
Sorry. I live in Davis.
The Target site in Davis. That was,
There's two big Superfund sites in Davis.
Yeah.
I don't know what was at the Target site. The other one, there's radioactive beagles that are buried down by a creek in Davis, which is beagle. Yeah, it's when they were doing, they're all beagles from when they were doing studies on them at UC Davis. And they would expose them to different levels of radiation and see what happened. And then buried them all when they got done. So there's just like a giant pit of radioactive dog bones. Yeah.
These two. There's like a
Yep. All campus landfill.
Quinn Davis doesn't pump groundwater.
No, we're all
So,
surface water now. Well, we were groundwater.
we
for a long
were,
time.
oh, well, it's the most recent change of the whole water
So much better
transportation
now.
system. Why do you say that?
It's like, you don't get all the hard water stains on everything.
Yeah,
It's a
hard
long
water
time.
was an issue when I was in college.
If you boil spaghetti, there'd be the
Yeah.
grit.
You guys hadn't noticed?
Oh man. If you have a good water softener, it's less of an issue.
Yeah, the SoCal's so bad.
Oh yeah. It's all that groundwater. Plus, the more times you use it, the saltier it gets. All right, everybody finding stuff? I'm gonna take this one down. The scorecard site's pretty darn good.
Yeah.
All right. So, let's take a break. We'll take 5 minutes and we'll come back and move into RCRA. We don't have a presentation today. I feel like we need a break in the middle of class to go potty and stuff. So we'll start back up at 2 o'clock on my clock, which would be like 1:59 on that clock, I think. I don't have any worksheets or any presentations, and I really want to eat my apples. So we need a break.
Just teaching all the way through.
I just can't do it. I've lost my stamina now at this point in the semester. I'm running off fumes.
Didn't know it was sort of stuff. Yeah.
Yeah.
There's not things I need. I told my brother that one.
There's three super fun sets in this.
Like, wait, so we're doing, we only live like, we live on like the outskirts of
There are four.
Lakesdale area.
What's at the
which is,
Target
like,
site?
I don't know if you know the streets.
I'm looking at Encino now. There's
Oh.
4 in the San Fernando Valley
Okay.
alone.
On the other side of town, basically,
Yeah.
if you're coming to the
I don't know, what do you, because it was just those 2, oh, so it wasn't for the nutrition
He
itself.
was like,
Yeah.
No, they were for the chickens.
Yeah, the
Oh, it's
Food Creek
fertilizer.
Farms is Denby. Is it fertilizer plant?
Yeah.
That'd be for sure.
So what is that even, that's just a place where they would dispose of fertilizer?
Or byproduct or whatever.
Let's see. Frontier Fertilizer,
BNSF versus the United States. BNSF is the case for
Is this, yeah,
BNSF,
North,
the United States.
Yeah.
Chemical
yeah,
company
nice.
Army.
Yeah. 1982 to 87, delivering pesticide and herbicides, non-volatile
Just make yourself.
chemicals,
Stuff
drugs,
split.
More about actual health.
Oh,
I'm very concerned. I'm like, how do I know? Like, I don't know. What is the problem?
Dumping unused pesticides and fertilizer.
So is that under with that development?
So there's not, so it's right next to it. It's all fenced off.
Oh, right behind it.
Yeah, you can't, you'll see it on the second street.
It's just dirt.
Mm-hmm.
Huh.
Did you see that?
So, who owns that land?
I'm not sure it's, it might, it probably says in there someplace.
Yeah.
Did I just not?
I don't know. I don't there much.
It's a huge stretch of land.
Did you say something during our? That's not.
Have you signed up for the fresh corner?
To.
I put it for the,
Yeah.
because it's fun, I need to pick which one.
Is that in Arbory?
Did you? Yeah. And I'm gonna be out of town that first, week before our prep, so. There's one.
They're all big, like, they're all online.
Yes, and that's,
Arbory has
that's
in
on.
person also.
Yeah, maybe I'll email her about that. And ask her if there's supposed to be something. Cause there's a assignment created for it. I just don't think we need to like.
What? Arbory?
Did you?
They do like rocket scientists, rocket science out there.
And mine
Yeah,
isn't.
mine too.
Yours isn't, but.
I mean, it's chill in terms of days, but it's not, it's just,
Yeah.
it wasn't just sprinkling, admin,
I'm worried about it. Yeah,
moisture
in Ocean City, like, you know, you go uphill from that, you go over the foothills, and there's a couple big drinking water lakes up there that are all fenced off. And like every time we drive by, there are enormous largemouth bass sitting up there, just waiting that no one fishes for. Totally be worth going in there tonight.
Plus, no one eats bass anyways.
It's true. Yeah.
Gross.
Especially out here.
Except stripers.
There's full mercury. So.
Yeah.
There's always something.
Don't rain on my parade.
Just limit the number you eat. That's the key.
I usually throw them back anyways.
Do they're not having a lot of mercury?
Hmm?
The stripers are not.
Yeah. I
That's
mean,
what my stepdad usually.
They're real fun to
He
catch.
catches.
they're awesome to catch. I love them. Basically, any predator fish out here is going to have high levels of mercury.
Yeah.
It bioaccumulates, and so all the little fish eat, and they get mercury, and then every big bass that eats this, all the mercury from that goes into the bass. Wow, that's awesome.
This is done by what?
Nice.
But pretty good.
That's a big, healthy fish.
This one.
Oh man, that's excellent. Nice color on those guys.
Yeah, it was really good.
Jeez.
The male tasted much better than the female. The female roe, we use that first.
For the steelhead.
Yeah.
Nice. We went out for steelhead on Friday. Didn't get anywhere on the feather. But saw a couple guys with a guy that got a half pounder that had a nice hand on it. Popped them off, but they're out
Those
there.
are really tricky to catch.
Mhm.
And they're super aggressive too. They fight real hard.
Yeah, I had the kids with me, which makes it a little bit trickier to do it, but
But they're out there, that's good.
mhm.
Learning.
It was a good day.
Yeah, fishing is better than them. They stay at work.
It's true. We had been out there longer, but it started raining, and the kids were not gonna put up with that.
No. Yeah.
All right, so Rick Rub. So RCRA deals with transportation, storage, and disposal of solid waste. Solid is a misnomer. It's not actually solid waste. So just get that out there right now. When we say solid waste, don't hear solid waste. It's basically just waste writ large. So waste is a huge problem generally. When we have growth in technology, growth in affluence, inevitably tied to that, we have substitution of man-made materials for biodegradable materials, and a disposable culture, right? How many of us carry hankies to blow your nose on? We use napkins, we use paper towels, we use Kleenex, right? It's probably more hygienic, but it also means we're generating a lot more trash. That's just, a little example. You get your iPhone. I've got an iPhone that's like 2 years old, and it's slow, and there's not enough storage space, and I definitely need a new iPhone. It's 2 years old. That's a really expensive thing with a lot of technology and a lot of very environmentally expensive components in this thing that's only 2 years old. So we have a very disposable culture at this point. And the things we're disposing are generally man-made, not natural. They're not biodegradable, right? Like plastic forks, for example. It's kind of incredible that it's easier to extract the oil from the ground and refine that oil, use that oil to make plastics, make that plastic into a fork, and use that fork once and throw it away than it is to use a regular fork and then wash it. But it's cheap and easy, so we do it. And that means we generate a lot of waste. On average, we generated about 2.5 pounds per person every day in 1960. By 1986, got up to about 3.5 pounds. Today, we're about 4.5 pounds per person. And that's, so course of a week, you're looking at, over 30 pounds of trash per person. And that's just the stuff that we generate from end use. Plastic bags, wrappers from containers, your plastic forks, your plastic spoons, water bottles, all that stuff. So 4.5 pounds per person per day. Overall, that brings us to, as of 2012, about 251 million tons of trash. About 87 million tons of that gets recycled. So that's a huge improvement. Historically, when RCRA was passed, for example, we had no recycling going on at all. So up to about 34.5%, 35% of our trash gets recycled. But that's all consumer waste. The much bigger thing is industrial waste. In the United States, 7.6 billion tons of industrial waste per year. So all the extra stuff involved in making that fork, for example, right? Or all the extra stuff involved in making that, not the iPhones, since those are all made in China. I don't know, pick a car, a Toyota that's made here in the United States. Huge amounts of industrial waste, and that's got to go someplace too. And so in 1976, federal government passed the Resource Conservation and Recovery Act, RCRA is how we pronounce that, which set out national goals for protecting human health and the environment from the potential hazards of waste disposal, to conserve energy and natural resources, to reduce that huge amount of waste that's being generated, and to ensure that the wastes are managed in an environmentally sound manner. The concern really here is land-based disposal. The federal government's hook was we have only a limited amount of land and we've got dumps all over the place. As of 1976, these dumps were not sophisticated things. There were holes in the ground where you dumped stuff. That was really just about it. Very different than what we have now and different than what we required under RCRA. So the state's role in RCRA is essentially to, just like the Clean Water Act and Clean Air Act, develop a state-specific implementation plan for RCRA, get that approved by the EPA, and then take over administering RCRA within the state. If the state doesn't do that, then the EPA comes in and will do it, and there's a lot of federal funding tied up in this. That federal funding hinges on the EPA's approval of a solid waste disposal plan for the state. And the states programs have to be at least as stringent as RCRA. Again, that kind of cooperative federalism model. States could go higher than RCRA, but the baseline is they have to meet what RCRA requires. So the way it works, kind of overall, our high-level view of the statute. First, the statute defines solid waste. Then it creates a tracking system for hazardous waste in particular, from its creation to its disposal. That's that cradle-to-grave approach to regulating hazardous waste. Establishes handling standards for non-hazardous solid waste from generation to disposal. So what do we do with all of the solid waste, the stuff that just generally goes into a landfill? And gives authority for mandatory cleanup of polluted TSDs, treatment, storage, and disposal sites. Those are the places where hazardous chemicals ultimately end up. So this is kind of the big thing. Regulates non-hazardous materials and how we get rid of those in landfills, tracks hazardous materials, and regulates how those are stored, moved around, disposed of, ultimately requires cleanup of any of these sites, the TSDs that fail to hold or to handle those hazardous wastes correctly. All right, everybody good with that so far? Cool. So the big parts here, there's solid waste program, which is subtitled D, and that really is what, through that grant program, through giving states authority, what encourages the states to develop their own plan for how they're going to manage their non-hazardous waste. This is like normal household waste, normal industrial waste that's not hazardous. It creates the criteria for these solid waste landfills and prohibits just general open dumping of this stuff. There has to be special receptacles, right? Sanitary landfills to put this in, and you can't just dump it anywhere. Subtitle D is a hazardous waste program, which is what we usually think about when we think about RCRA. Although this is really, subtitle D is a huge part of it, but subtitle C is the hazardous part. That's that cradle to grave tracking and essentially requirements about what you can do with those listed chemicals, those listed wastes. And there's also, we're not going to talk about this one, but there's an underground storage tank program. That's subtitle I, and that addresses all of the underground storage tanks that have hazardous materials, largely petroleum products. If you have an old gas station, for example, you have underground storage tanks for that gasoline. After that gas station closes, those often don't get ripped out, they just get left there. And that's a big problem, you gotta deal with that somehow. Yeah?
Do they go back to the original owner to pay for anything like that, or is that completely
Yeah.
specific program?
It depends. If they're older and they fall under Superfund, then we go into the whole potentially responsible parties thing, which we'll talk about when we get there. If it's newer stuff, then they're supposed to be tracking that, and then you can go in and kind of figure out who actually has the liability. It's hard because a lot of those companies go bankrupt, then who could you pay for it at that point, right? And again, the coverage here is for solid waste, but solid waste doesn't mean solid waste. So the Act itself defines solid waste waste as any garbage, refuse, sludge from a wastewater treatment plant, water supply treatment plant, or air pollution control facility, and other discarded materials, including, under solid waste, solid, liquid, semi-solid, or contained gaseous materials. So solid includes solid, liquid, semi-solid, or contained gaseous materials, resulting from industrial, commercial, mining, and agricultural operations, and from community activities. So a very broad definition. There are things that are exempted, and that's probably the easier way to think about this. Solid or dissolved material that's in domestic sewage, before you go in and you pull out the sludge, everything that's in that domestic sewage stream is not covered by RCRA. What's that covered by? Clean Water Act, good, right? So secondary standards apply to that until it gets in, and then once it's in, you have to go through the standards for the publicly owned treatment works before that can be discharged. The stuff that's left, that stuff's covered by RCRA. Okay. Solid or dissolved materials and irrigation return flows. Ag largely gets off from RCRA concerns with those irrigation return flows, same as we see under the Clean Water Act. We just generally don't regulate irrigation return flows. Industrial discharges, which are point sources under the Clean Water Act. So if you cover these discharges under some other act, Clean Water Act or Clean Air Act, if any of those things apply, then you don't consider it solid waste under RCRA. Then there's some special nuclear or nuclear byproduct material or nuclear source material as defined by the Atomic Energy Act that's also not covered. Oh, I got that in there twice. That's great. All right, so if it's solid, then the next question is it hazardous? If it is hazardous, then we go to that subtitle C, and we have all the hazardous requirements that apply. If it's not hazardous, then we go to subtitle D, which is the essentially landfill part of this. All right. EPA has fleshed this out as has fleshed out solid waste and discarded material in its own regulations. And solid waste, the way they define it, is essentially any discarded material that has not been excluded by regulation or by some other variance. So discarded material then is abandoned material, recycled material, material that's considered inherently waste-like, and military munitions. Abandonment, this goes back to like the property question of abandonment. Is this deliberately an abandoned thing or not? Recycled material is looped back into discarded, and then this is where you see the finding, material that is considered inherently waste-like. Right? What does inherently waste-like mean? And we run into real problems with this for timing, like at what point does it become discarded material, and this question of recycling. If we're going to recycle it in order to reuse it, like if we're using the same chemical without changing it at all, maybe it's not waste at that point. If you're stockpiling it for a while in order to get enough that you can process it and turn it into something different, it probably is waste, but then it also becomes part of the process to create something new. And so dealing with those things are all very tricky. All right, so I think we read 2 cases. This may be the shortest case in the whole book. It was like literally 1 page. So No Spray Coalition Incorporated v. City of New York. What is this one all about? Anybody want to give us a quick rundown on the facts?
We were spraying some sort of insecticide in New York to kill mosquitoes that potentially had West Nile.
This is when West Nile's like taking off, right?
Yeah.
Suddenly it's a thing.
It's an interesting argument on the plaintiff's side, but they were looking for an injunction against renewing the spray program.
Mm-hmm.
And the court essentially held that they were arguing that the insecticide was like a waste product.
So as soon as you spray it,
It was waste.
it's out of your control and it becomes waste at that point. That's the argument because you're done with it, right? You've released it into the atmosphere. Okay.
But I guess that what the court held was that it wasn't solid waste because it's not discarded until it had served its intended purpose, and we can't tell when all of the mosquitoes have died or.
Exactly.
It's like,
So what's the intended purpose of the pesticide?
was to kill the mosquito, and we don't know how long that would take. It's not like a defined.
As long as it's out there killing, right? As long as it's still in pesticide form, it could potentially be killing these mosquitoes. So, okay, maybe it's still serving its intended purpose. At some point, it's not, but we don't know what that point is, and maybe that point is when it breaks down to the point that it's not effective any longer, right? So court says, no, it's not discarded, so you're not covered by RCRA until it served your intended purpose. Then we get an interesting case, Connecticut Coastal Fishermen Association v. Remington Arms Co. The fisherman versus the hunter. We've got a skeet and trap shooting club, and they're with their shotguns, they're shooting out over Long Island Sound, right? So the little clay pigeons go wobbling out there, and then they shoot them with their shotguns, and there's lead all over the bottom of Long Island Sound. And so the question then in that case was whether lead shot and clay targets that are out there are waste. Have they been discarded or not? And what did the court do with that one?
The court determined that they're considered solid waste because it's like it was a temporal argument. They've been there long enough. I mean, I don't know, it was such a small excerpt, but it's like, they've been there long enough and they could have removed them and they hadn't, and so now we're calling it solid waste,
So at some point, and we don't know when, the court like explicitly doesn't determine when it happened, but at this point we know it's already happened, that it's transitioned from serving the purpose, which is what, breaking clay pigeons, I guess, improving marksmanship in this case. And at some point, it's been out there long enough that it's no longer serving that purpose. They're sitting on the bottom of the ocean, or Long Island Sound, part of the ocean. And at that point, we no longer have a solid waste. All right, what page is that on? I can't find it. 44, thank you.
It's note 6.
Yeah, there we go. All right, and that brings us then to there we go. Waterkeeper Alliance v. U.S. Department of Defense. So what's the situation here?
First of all, Vieques is awesome, so.
Is it a great place?
Yeah.
I've never been to Vieques.
They've got one of those bioluminescent bays,
Ooh.
right?
I swam in one of those in Costa Rica. I was doing bat research and jumped off the dock at like 6 in the morning. I kept seeing these flashes of light. Freaked me out. It was scary. And then I found out what was happening and it was kind of cool. But why is there lightning all around me in the water?
That's good, it's gonna have power right now.
At least this way they'll have light. That's good. Maybe the hurricane washed away all the leftover munitions.
I mean, it's all military,
So what's happening here? What's the argument?
Dropping bombs and shooting stuff on the island.
Military doing what the military does, right?
Yeah.
Marksmanship practice, bombing practice, gunnery practice. So
We were seeing all the lead essentially and ammunition that was on the island was waste, like solid waste. And the Army or Department of Defense argued that they could go. Didn't they argue that they could go in there and retrieve it to? I thought that's what.
So what purpose is this? First of all, temporally, what are we arguing about this stuff? It's kind of a weird thing.
Like you've already used the purpose once it's hit the ground, and you determine if you hit the target or not.
But in the Waterkeeper Alliance, I'd really like to see the briefs in this case because it seems like they've made a strange argument. Because the court's focusing on like after it leaves the gun and then once it hits the ground, at that point, is it waste or not, right? And it seems like you could have argued based on Connecticut Coastal Fishermen that at some point, we don't know when, but at some point it became waste. This stuff's been in the ground for 20 years. That part of it's definitely waste, right? But the court doesn't focus on that, and it focuses on it like after it leaves the gun until it hits the ground, and then at least a little while after it hits the ground. What does the court conclude about that?
It's we're using Connecticut and saying that the court's language strongly suggests that the munitions must accumulate for an unspecified amount of time before they can be considered discarded material and solid waste. And it just didn't, specifically like you said earlier, didn't put a time frame on it. And
The bottom of 45, they like focus in on this particular question.
Are you referring to the defendant's argument that they're saying that's what the purpose is to
Yeah.
inhabit land, make contact with land?
Yeah, exactly. So the court says the parties' disagreement can be distilled to the following: whether as soon as the ordinance is fired, it makes contact with the land, it is discarded material. If not, then it's not solid waste. They can't bring this lawsuit. And then exactly what you said, the defense argues, hey, look, this is the point of this, right? Just like the point here was to have this pesticide floating around killing mosquitoes, the point of shooting this stuff is to shoot it and have it hit the ground and kick up some dirt or some smoke or something, so we know where we're hitting when we shoot these big guns. So the court ruled, based on this kind of same logic that we see in the Second Circuit, that this material has not yet served its intended purpose until after it's in the ground. At some point after that, it probably becomes something that's been discarded, and at that point would be waste under RCRA. But that hasn't happened kind of during this initial part. When you first shoot it and hits the ground and kicks up smoke, then at that point it's doing what it's supposed to do. All right. And so the court ultimately rules that RCRA does not apply in that case, at least based on the way that plaintiffs made the argument there.
It seems crazy though, because maybe you give them like a day or so to go see where it's hitting the target, but like after determining where it's hit it.
It's a rough edit because we don't know why the court's so focused on that part of it. Either maybe they didn't argue the longer view, or if they argued it for some reason, the court interpreted RCRA to just focus on that first part and not the longer view. Not clear to me. Part of it, I think, is frankly that it's military, right? And we're going to get some special treatment in the military, especially around environmental issues. The court talks about that a little bit. And if you go and you look at generally at the way that we treat island nations and the way we use those, the military tends to use those places, not pretty generally. Marshall Islands may be the best example of the nuclear explosions that we had there. Many of which were much more powerful than they thought they were going to be, and so they ended up being fallout all over the citizens of other Marshall Islands have been relocated, and there's islands you still can't go to because they're radioactive, and yeah. Anyway, there's a long history of this. I think this decision you can also read as just part of that same long history. So I do think this, though, is the accepted version of when something's discarded. There's just not a whole lot of case law on this. All right. The other thing you'll see, we talked about the recycling. People can start to gather materials claiming that they're going to use these things in the future, because if they are going to use them in the future, then you can keep them, from having to dispose of them under RCRA. It makes it easier to have these things. You don't have to worry about the whole disposal part of it. And so the EPA has cracked down, in particular on these, we call them speculatively accumulated materials. Things you accumulate, hoping to use them in the future, but you don't really know if you're going to or not. You can't just keep barrels of this stuff on your property indefinitely saying, oh yeah, that's not waste, we're definitely gonna use that again in the future. Right? At some point it becomes waste. The EPA says through regulation that we treat these as discarded and thus as waste if there's no viable market for those materials, or if the entity has not used 75% of the accumulated materials within a calendar year. This is like when you go through your refrigerator at the end of the year and you clear out like the old chicken stock and all that stuff, right? You can't just keep it around forever and hold it in your fridge. If you haven't used 75% within a calendar year when you generate it, it's no longer stuff that you're going to use again, and we just treat it as waste at that point. Sham recycling, same kind of thing. Companies will gather the stuff saying, hey, we're going to recycle this, we're going to recycle it in order to just hold on to it. And the EPA looks at kind of a three-factor test for this. Whether the secondary material is effective for the claimed use. Are you actually able to do with this material what you say you're going to do with it? If the secondary material is used in excess of the amount necessary, if you only need a little bit of the solvent and you're using a ton of it because you have a ton of it, because you're holding on to it, because you don't want to have to dispose of it as waste, and whether or not the facility has maintained records of the recycling transactions. Can you actually show that you're holding on to this and selling it, or finding some way to reuse it? Can you demonstrate that you're actually successful with recycling it, not just pretending to recycle it in the future? All right, questions on that? All good? Okay, so we can look at RCRA then, kind of back up for just a second. First trigger we look at is there solid waste? If not, then RCRA doesn't apply. Remember, we're very broad definition of solid waste. Essentially everything goes into it except the stuff that's specifically carved out. So is there solid waste? If not, RCRA doesn't apply. If yes, then you look at, is this waste hazardous? And if no, we go to subtitle D. If yes, we go to subtitle C. And we get specific requirements for the generators of the waste, the transporters, and where it ultimately ends up, the TSD facilities, treatment, storage, and disposal facilities. So first question, is it solid? Second question, is it waste? Is part of that first box, right? We talked about solid first, and we spent some time now talking about what does waste mean? Is it something that's actually being discarded or not? Okay, everybody good? Everybody oriented to this? All right, so subtitle D sets out minimum requirements for state landfills. States can have higher requirements. The essentials here are no discharge into surface water. You can't just have water running off of your landfill. You can't be dumping it into a stream and call that a landfill and let water flow through it, carrying it away. You can't just openly burn stuff. You can't have a giant burning pit that you're dumping all of your trash into. And then the groundwater has to be protected. So how many of you have been to a landfill? Have seen how a landfill works? It's a pretty good number. Wow, I'm impressed. So you go in there and there's like bulldozers compacting this stuff, and you can't really see it underground, but there's like multiple levels of plastic, and then clay, and then plastic, and then clay on top, and then you put all of your trash in there, and you compact it all in with bulldozers. I'm not going to draw a bulldozer, that's not going to work. And then eventually, you cap it with plastic and clay, and you put dirt over the whole thing. You put in some pipes, let the methane out. You can use these pipes to generate energy. You can actually make little power plants around the methane that comes out. You burn it, and then all around on the outside, you sink wells that will tell you if there's any leachate, which is as delicious as it sounds, any leachate coming out of the bottom of the landfill into the groundwater. And so you're constantly monitoring that with monitoring wells around it. And the thickness of these things, the number of plastic layers, the thickness of the plastic layers, that's all established. The minimum, you can have, again, higher requirements state by state, but the minimum things are set out by the federal regulations in this area. So definitely worth checking out if you're interested. And the other part is you have to have a plan to prevent introduction of household hazardous wastes. What do you think the most common household hazardous waste is that we're introducing into these landfills? Prescription drugs are a big one. I don't think they're the biggest though.
Motor oil. Seeing like motor oil and paint.
Motor oil and paint are big ones. Yeah, other big ones?
Is motor oil still a thing though? I mean, does
Batteries, yeah.
people still do that?
The people in Kansas do. No, there are people in my neighborhood who still change their own oil. And you have to, places that do oil changes have to accept the oil that people bring in and change their own oil. Because the worry is that if you had to pay to dispose of it, people would just like dump it down the drain or dump it in the shower, or what, probably not in the shower. And then the garbage disposal, that way you wouldn't notice. So the cities have to have a way to try and keep those things, the paint, the prescription drugs, the motor oil, batteries, I think somebody said batteries are a big one. Light bulbs, all of our like fancy LED light bulbs have hazardous chemicals in them, and then all the fluorescent lights, all those tube lights, have stuff inside them that's also toxic. So if you're like a really environmentally sound person, you're saving those batteries, you're saving those light bulbs, and you're taking them to the hazardous waste disposal site to dispose of them.
I think like Best Buy or some Targets also have
Yeah.
recycle facilities for certain.
I think Best Buy and Office Max will actually give you like credit back on if you bring in a battery. They'll give you like it's not very much, but they'll give you some inducement to do it. So don't put your batteries in the trash can. There's signs on the trash can that say don't put your batteries in. Some cities you can put the batteries in a bag on top of the trash, and they'll collect those and take those and put those at the hazardous waste sites. A lot of them don't. Most cities have, or all cities have, a hazardous waste location that you can take hazardous waste to. You usually have to call in advance, give them an idea of what it is you're going to bring in, and then you show up with these boxes, whatever you have, and they'll take it off your hands. And then what else? Put the batteries.
Does that apply to like small batteries too?
Yeah, every battery. because they've got acid, lead and acid in there. Lead being probably the bigger part of it, but nickel, a bunch of other chemicals in there, a bunch of other materials in the batteries. And then electronics, so you can't like throw away a computer or a TV. Those are supposed to go through the electronics recycling programs. As you might imagine, this doesn't work terribly well. Like even the most environmentally sound people still make mistakes or have lazy days or whatever, which is one of the reasons it's so important to have enough layers of clay to monitor your groundwater, so at least you know what is coming out of this if there's anything coming in. It kind of looks like a crab, doesn't it? But yeah, so they're supposed to try and prevent the introduction of hazardous materials. Hazardous materials broadly are covered, as we said, in subtitle C. The requirements of C apply to any solid waste once it's identified as hazardous. There's all kinds of criteria we look at to decide if it's hazardous or not. And then once you have hazardous materials, there are regulations, requirements created by those regulations applying to 3 different categories of entities. So here's our flow chart. Is it a solid waste? Look at the used motor oil management stuff, it's kind of separate. If it's not used motor oil, if it's a solid waste, you look down and say, is it excluded from solid waste regulation? If not, is it excluded from hazardous waste? If not, is it listed hazardous? If yes, you have a hazardous waste. If not, you look at, does it exhibit a hazardous waste characteristic? If so, then you have a hazardous waste. If you get yes, it's excluded, or no, it's not solid waste, the RCRA doesn't apply. So these are the 2 ways you can be a hazardous waste. You can be a listed waste or a characteristic waste. Not you. I shouldn't use you, I guess, when I'm talking about.
Sounds like a Schoolhouse Rock.
It does. We should make a Schoolhouse Rock video. All right.
Sure. So instead of a final, sure.
Yeah. That's it'd be easier for me to grade. There's a lot of. I need to rethink this course.
Easier to grade.
Yeah.
Put it in school systems,
We
charge
could
you credit.
We could be doing all. Wow. Okay. Focus. So this question of is it a hazardous waste? Hazardous waste is a solid waste or combination of solid wastes, which because of its quantity, concentration, or physical, chemical, or infectious characteristics may either A, cause or significantly contribute to increase in mortality or an increase in serious, irreversible, or incapacitating reversible illnesses, or B, pose a substantial present or potential hazard to human health and the environment when improperly treated, stored, transported, or disposed of, or otherwise managed. So that's our definition that comes out of the statute. But the way that we go about applying that definition is through these 2 different categories we talked about. So listed wastes or characteristic wastes. Listed wastes are specifically listed by the EPA. Makes sense, right? That's why we call them listed wastes. So there's a small list out of the 50,000 or so chemicals commonly used in commerce. A very small list of those are listed wastes. Most things fall into the hazardous designation based on being a characteristic waste. And these are wastes that show one of 4 hazardous characteristics. They're ignitable, meaning they burn easily under kind of normal room temperature conditions, or they're very easy to ignite. Corrosive, very strong acids and bases. They can eat through metal. Any of those things make them corrosive materials. Reactive materials, which are unstable with potential to explode, react violently with water, or produce toxic fumes, or toxic wastes, which have the potential to release toxic substances and toxic concentrations, toxic for people, toxic for the environment, if handled incorrectly. So listed waste, decided based on whether you're on the list or not. Characteristic wastes, you look at the waste and say, does it fall into any one of these 4 categories? And the EPA actually sets out tests for determining whether you meet those categories or not. So by regulation, there's tests that you can put a material through to decide if it's ignitable, to decide if it's corrosive, to decide if it's reactive. All good? Okay. So these things are treated very differently. For characteristic wastes, if you can treat them, mix them, dilute them, whatever, so that they don't show that characteristic anymore, then it's no longer a solid waste. So if you have something that ignites and you can make it so that it doesn't ignite anymore, no longer a solid waste. The book gives the example of you've got some hydrochloric acid, you've got a very concentrated acid, a very concentrated base. Both of those are characteristic wastes. You mix them together, they turn into water. Mix them slowly because it releases a lot of heat and fumes and stuff. But if you did it slowly, you'd end up with water, pure water and salt, table salt. And if you do that, then that's not a waste anymore. It's no longer a hazardous waste. You don't have to worry about RCRA at that point. So characteristic wastes you can still get out of RCRA. Listed wastes, you can't. Once you're listed, you stay listed. Listed wastes are the wastes that you really don't want to have. If you mix it with something else, whatever you mix it with is now considered hazardous too. So if you dilute it, the stuff that you dilute it into is hazardous waste as well. So you've created more hazardous waste than you originally had. So that doesn't work. If you derive something from treatment of hazardous waste, then whatever you've derived is also treated as hazardous waste. So if you had two hazardous wastes that would cancel each other out, you mix those together, it's still going to be considered hazardous waste. And contained in policy, whatever you put that hazardous waste into is also considered hazardous waste. So if you have like a 5-gallon bucket of hazardous waste and you put that of listed hazardous waste, you put that into, they make big containers for holding hazardous wastes. You put that bucket into a bigger bucket and you close that big bucket. Now that big bucket is also considered hazardous waste. So if you're going to get rid of it, you have to get rid of everything, including that big bucket that ultimately contains all the other stuff. So this is like, it's a gift that keeps on giving. You can't get away if you're a listed waste. It makes everything else listed wastes too. That means that in some cases you can have characteristic wastes that after treatment aren't considered wastes anymore, that are actually more dangerous than, say, a very dilute mixture of a listed waste. But we're still going to treat that listed waste differently. Just the way it is. All right. Questions on that? Cool. So we talked then about these 3 different entities that are regulated by RCRA. This is the generators of hazardous waste, the transporters of the waste, and the TSDs, treatment, storage, and disposal facilities. So generators, right, from the cradle to the grave. TSDs is the grave in this scenario. And we have requirements under RCRA for all these different entities. Generators, generation is what generators do. It is the act or process of creating, producing hazardous waste. They have to prepare, when they prepare that waste or when they create that waste, a manifest with an ID number from the EPA. So each generator has an ID number. They get this number, then identifies the waste that they produce, and that manifest, which says what the waste is, what the characteristics are of that waste, has to stay with that waste until that waste is disposed of, gotten rid of, treated to no longer be a waste. Basically, until you're out from under RCRA, you have to have that manifest with the waste all the time. That way you at least know what this stuff is that you're handling. They have to ensure proper storage of the waste on their own sites, properly label the waste on their own sites, and when they're preparing it for transport, keep records of what they generate, how much they generate, and any test results to see what's in that waste, and then submit periodic reports to the EPA about what they're generating. So going back to those chemistry labs, or if you ever worked in a scientific lab, those labs often generate hazardous wastes that have to go to someone to get disposed of. And so if you have a little container to hold hazardous waste, you have to keep track of what waste you're putting in there. So that you end up, at the end, you've got a mix of these 4 different chemicals in this little container. And if you don't have that, then you get in big trouble, and hazardous waste cleanup teams have to come in to deal with it. And so you have to have all that information on there, prepare your manifest, and then that goes off like within the university for the university to combine it and ship it with whoever's transporting and ultimately storing or disposing of that hazardous waste. All right, so those are our requirements for generators. Transporters have to comply with EPA and Department of Transportation requirements regarding labeling and placarding. So labeling both the chemical and the truck, so that if there's an accident, one of the trucks that's hauling the stuff on the road, you know what it is that's being released. Firemen who respond, first responders who respond, know what they can and can't do, what kind of protective gear they need in order to respond to accidents addressing or involving this waste. They are required to accept only properly labeled waste. So the generator has to label it, and then the transporter has to make sure that it's properly labeled before they take it. They have to keep that manifest from the generator. They have to deliver waste to a designated facility. You can't just dump it on the side of the road. You get in trouble for that. So take it to a TSD facility. There's a lot of this stuff moving around. 3 billion tons a year of hazardous waste. 800,000 shipments every day. You can pay attention when you're on the road. And if you learn to read these placards, you can tell what kind of hazardous wastes are being hauled with the placards. So flammable liquids, you've got gasoline, fuel oil, flammable versus combustible. You've got corrosive materials, acids or bases, radioactive materials, poison, inhalation, all kinds of different things. So keep an eye out when you're behind the semis traveling up and down the 5 or the 99 or whatever, and you can get an idea of which vehicles are actually carrying this stuff. There's big fights over the radioactive one. The question, if we start moving nuclear waste around, are you supposed to label these trucks or not? The thought is if you label them, then they become targets for terrorist attacks because you could release a whole bunch of radioactive material all at once. But if you don't label them and then they get in a wreck and you've got your highway patrol officers, your firemen responding, and you've got radioactive material everywhere and they have no way of knowing that, you run into big problems there, right? So we see lots of fights about exactly how this labeling should be done. So the big focus for RCRA though is these TSDs, the transportation, the treatment, storage, and disposal facilities. These are the facilities that ultimately take possession of all these hazardous wastes. They get a permit from the state or the EPA. They're required to operate cleanly, train everybody, keep extensive records, monitor to make sure they're not releasing any stuff, any of the hazardous wastes. Keep the manifests around from all the shipments they've ever gotten so that people know what's being stored there. When they shut down, they have to do what's called a clean closure. So they maintain and monitor the site for at least 30 years. They have to have bonds that will pay for that process, the monitoring, maintaining, and for any accidental releases from those sites. And then they have to perform corrective actions as needed at their sites, both spill cleanup on site or spill cleanup that starts on site and migrates off sites. So these are the folks who ultimately take possession of this stuff. They treat some of the materials. They store some of them because there's just not a good way to do anything with them. And in some cases, they're able to dispose of these in special landfills with extra thick liners, a whole lot of extra monitoring equipment, kind of all of that extra protection. So storage is defined as the containment of hazardous waste, either on a temporary basis for a period of years, either on a temporary basis in such a manner as to not constitute disposal of the hazardous waste, or for longer terms. But it can't constitute disposal because you want to keep it from falling into the generation of new waste. Treatment is any method, technique, or process, including neutralization, designed to change the physical, chemical, or biological character of the waste so as to neutralize it or render the waste non-hazardous, safer for transport, amenable for recovery, amenable for storage, or reduced in volume. So either treating it so it's not as bad, or treating it so that there's less of it, or it's safer to handle. And then disposal is the discharge, deposit, injection, dumping, spilling, leaking, or placing or of any solid waste or hazardous waste into any land or water so that such waste or solid waste or hazardous waste or any constituent thereof may enter the environment or may be admitted into the air or discharged into any waters, including groundwaters. So it seems like there's supposed to be a no in there, but there's not supposed to be a no in there. This is any way, disposal is anything that might ultimately release the hazardous waste to the environment itself. We're going to skip over the siting stuff for now. So in 1984, we enacted a whole bunch of amendments to RCRA and essentially instituted what is called the land ban, which was a short-term ban of the disposal of any hazardous waste into landfills or salt domes or any of the other places that we store this stuff. Essentially, it restricted it until or unless the EPA administrator determined that the prohibition was not required in order to protect human health and the environment. So you hear about the land ban, but the important thing to remember is this is a short-term ban, and generally now we still permit land disposal of hazardous wastes, but only into those facilities or in those ways that the administrators determined are not going to damage human health and the environment. Lots of ways to treat this. You can look up the land disposal requirements there. And so then RCRA liability is the last part of this. RCRA altered the liability standard to create strict liability. If you are a generator, a transporter, or a treatment, storage, or disposal facility, and anything happens, if there's a leak, a spill, any of it, if you were responsible for the waste at that point, and it happened, then you're liable, period. It doesn't matter if it was your fault or not, it's a strict liability scenario. Okay? We see that a lot with stuff like toxics. Think back to torts. Anytime you have a inherently dangerous activity, a lot of times you see that strict liability standard. And that's what we've got here. TSDs, as I said, have to clean up the spills. Civil liability is the default, but you can get criminal liability for essentially actions that show that criminal mens rea, right? That you're deliberately doing something. It wasn't an accident. You did this on purpose. You're covering something up. All of those bring out criminal liability. All right, and that is RCRA. Any questions? Yeah.
Was strict liability for hazardous waste and solid waste, or just hazardous?
I think it's just for hazardous, but I'm not for sure. I'll have to look and see. That's a good question. I promised a video, but we don't have time to start the video, so we'll have to do the video next time. It's a good video. I think we're past the deadline. It's too late. So we will start the video next time. It's a nice love canal video. It's not romantic.